Alright, welcome back to class. We are currently finishing up our Algebra 2 lesson from yesterday, which was the division part. This was the video that I made that I forgot to hit record on. So I went ahead and broke it into two parts and did the multiplication yesterday. And now I'm going to work on the division. I've changed my camera setup a little. I know there's still a big glare right in this area. And I'm working on that at this current time. I can't get any lighting to me, and my room in here is pretty dim. So as soon as I find a better setup, hopefully the videos will be a little bit better. But I'm using my son's Canon EOS T5i, I think, today. I have no idea how to use it, so hopefully I'm staying in focus here. And I'm also using his Rode mic, so hopefully you can hear me good. If I do this video and it doesn't look better, or the sound is not coming through, then until I figure out how to use this camera, I guess I will go back to using my phone. So I guess we'll jump right in, and I kind of have it angled to block out some of the glare. So I hope I don't stand in front of the camera too much. I'm trying to go from this side, but I prefer to work on that side. So we'll see what happens. So if you are in my Algebra 2 class, division of roots and radicals, this is on page 202.01, I believe. It was the second lesson in your work packet. And if you're not, but you're doing some kind of radicals or need to learn how to put them in the same index or order, go ahead and follow along. The rules of multiplication and division are practically the same. Make sure to reduce the radicals to the same order. That's what this says if you can't see it. That is the big deal. If they don't have the same index, this little 3 and this little 3, you can't work them out until they do, which is the whole point and the long point of this. So on this very first problem, I'm going to go ahead and move to the right side, and hopefully I'm not blocking the whole screen. On this very first problem, we have the cube root of 54 divided by the cube root of 2. The good thing, they're already in the cube root. This is an easy problem. And you just do 54 divided by 2, because this is also written like this. This and this is the exact same thing, except for when it's all under the same radical, you can do the simplification of the fraction. So 54 divided by 2 is 27. So this would be the cube root of 27. Is there a perfect cube of 27? Absolutely. The cube root of 27 is 3. So that is the answer. Sorry for smearing that. I didn't mean to. If we move to problem 2, I have the square root of 60. It's a square root. We don't write the square out there. And then 2 times the square root of 5. So again, we have the same order, which is great. We don't have to do any extra work. Now, if I wanted to write this like I wrote this one, this 2 is on the bottom of the fraction. So when I write that, it would have to be looking like this. Okay, that 2's still got to stay on the outside, and it's still got to stay in the bottom. All right, so 60 divided by 5 is 12, so this should look like this now. Now, there is no perfect square of 12. However, we can break 12 down into multiples that have a perfect square, and what I mean by that is I can break this down to 4 times 3 with my half out here, and there is a square root of 4. Okay, I do that to get the radical as small as possible. Well, when I bring that square root of 4, it comes out here and it gets multiplied. Okay, so square root of 4 is 2, and because this was on the top, I need to multiply it by the top. So I bring a 2 out and multiply it there. So I have 2 radical 3 over 2. Because I used that, this is left in the radical. That is a sorry looking tooth. 2 divided by 2 is 1. So this actual answer is radical 3. That's a prime number, so I can't get a perfect square out of that, okay? So those are the easier ones on here. And then I have 3 more that are in a whole different realm. When we look at problem 14, I'm going to switch colors. I'm trying to decide what color shows up best on here, so I'll be switching quite a bit. On 14, I have the square root of 2xy cubed and the fourth root of x squared y squared. So they're not in the same order. So I need them to either both be fourth roots, both be squared roots, or both be sum roots. Okay, excuse me. Some people will want to go ahead and make this a fourth root. However, I can see that's a 4 and these are 2s, so there's going to be some reduction in there. I'm going to go ahead and reduce this bottom one, put it in fractional exponent form. So this would be x over 2, 4 and y 2, 4. The exponents inside the radical go over top of the index on the outside of the radical. When I do that, I can reduce 2 over 4 to 1/2. So this actually looks like x to the 1/2, y to the 1/2. When I put it back in radical form, it's going to be a square, so I don't need to go ahead and match them up. So if I rewrite this problem, right here, the 2 goes on the outside, but I do not have to write the square root. And x to the first and y to the first go inside, and now that is my problem, and I can work it because they both have the same order to them. There is no number down here. Remember, I can also write this like and then divide and simplify them out. And it looks like I'm going to have to move problem 23 over because it is in my way. Okay, so once I do that, the 2's got to stay because there's a 1 down here. 1 goes into 2 2 times, all right? X to the first and x to the first, remember when we have exponents and we're dividing, we subtract them, so there's no x going to be there. And then y to the third and y to the first, 3 minus 1 is 2. So this would be y squared, and it's still all under the radical, and that is the simplified answer. All right. Yesterday's video, if there is a number out here other than 2, like the 4 or something, it has to be in the answer. Second to the last problem I did yesterday on the multiplication, I forgot the 6 out there, and I was watching the video back, and I was mad at myself. Obviously, I can make mistakes, so you probably can too, but let's try not to. So 19 is a fraction over a fraction, and they don't match in the orders. So this is one of the harder ones, I would say, on the page, and we need to get them to match. I'm going to try to lower this one down, and how I'm going to do that is, this is a 6 that I just messed up. This is a 6. I need things that are multiples of 6 or 3, something that will go into a 6. I know 8 is a perfect cube. I could write this as 2 cubed. That's still 8. 2 cubed is still 8, all right? If I do that and I put this in exponent fractional form, I would get 3 over 6, which is 1/2, correct? So if I do that and I get 1/2, or this, it's not written like this. I don't know. I feel like I'm not writing it correctly. 3 over 6 reduces to 1/2. This fraction on the bottom is now, when I put it back in the radical, it's just going to be a 1/2 down there with no 6 on the outside. And when I do that, I still don't think I wrote that right. I'll have to go back and double check if it should have been down here or if it was the whole thing. But once I have that and I have this problem and they're in the same order, if you have a fraction on the bottom of a fraction, what do? You multiply by the reciprocal. You flip it and multiply. So really what I should have, and I hope you can see this, I don't know how far I am, but I should have 1/4 times 2 over 1. I just flip this one upside down and multiply. That's how you get a fraction off the bottom of a fraction. And so 1 times 2 is 2, and 4 times 1 is 4. So this is what I have. Okay, I still can't have a fraction inside the radical, but that is a perfect square. 4 is a perfect square, so that 2 is going to come out, and this radical 2 is going to stay inside. But notice that this was on the bottom, so that 2 has to stay on the bottom. And the radical 2 will stay in the answer, and that is my completed answer. So I got one more to show you on this lesson, and then we'll be done with it, and I'll move on to a different video. And that was problem 23, I think. So I will write it here. I'm gonna get this good and dry. Use a paper towel. Alright, I'm going to rewrite problem 23. And it is radical 30 minus Alright, you have a binomial over a monomial. So what happens there, this is problem 32. What happens there is you treat it just like you treat anything else. If you were doing 2x plus y divided by x, x would have to go into this term and to that term. So the same thing with the radicals. It needs to divide into this one and that one. The issue would be if they don't match. In this case, they match, and if y'all can get the ones that match, that's great. I won't be too hard on any of the rest of them in this realm because you're not in class and I'm not there to help you. So you say 30 divided by 5, which is going to give you radical 6. Right? 5 goes in there 36 times, and since this number is big up here, it stays in the top. And then radical 5 goes into radical 5. How many whole times? One whole time. This sign is a minus, so this is a 1. 6 cannot be broken down. So that is your completed answer. And that completes part 2 of the lesson of multiplying and dividing radicals in Algebra 2. Thank you. God bless. Have a great day.